Linear algebra previously asked question from CSIR NET. W1 be the subspace of R2 space with three conditions given, and W2 is also the subspace of R4 space with the conditions given. Then which of the following is true? Dimension of W1 is 1, dimension of W2 is 2, dimension of W1 intersection W2 is 1, and D part is dimension of W1 plus W2 is 3. So regarding the solution, we need to check which of the conditions are linearly independent in case of W1 first. So I'm writing the coefficients, like coefficient of U is 1, coefficient of V is 1, W is 1, X is missing in first condition, so it's 0. So likewise, we need to reduce this matrix in row echelon form. Operating R3 tends to R3 minus 2 times R1. First and second rows are same, condition is in R3. The change is in R3. Now we can see R3 can be totally made the 0 row by the R3 tends to R3 plus R2. So now we are getting only two independent rows. That means there are only two conditions which are linearly independent out of 3. So dimension of W, which was actually less than or equal to 4. Now with these two conditions which are linearly independent, dimension of W1 will be 4 minus 2, that is 2. So first option is incorrect. Checking dimension of W2 in a similar manner. Writing the conditions first. Writing the matrix in the coefficient form 1 0 1 1 1 0 1 minus 2 0 1 0 minus 1. Reducing it into row echelon form, R2 tends to R2 minus R1 first. Change will be in R2 only. Now I can easily check, I can just rearrange R2 by R3, interchange R2 by R3, but still I'll be getting 3 independent rows for sure. So 3 conditions are linearly independent. All the 3 conditions given in W2 are linearly independent conditions. So therefore dimension of W2 will be 4 minus 3, that is 1. So option B is also incorrect. Now we'll be checking about intersection and sum part. First of all, the intersection W1 intersection W2. It will be following all the conditions which were in W1 also as well as in W2 also. So it will be subspace of R4 with 6 conditions given to us, out of which we will be checking which of them are linearly independent. Obviously not all of them are linearly independent because the maximum dimension is 4. So this was first, this was second condition, third, fourth, fifth, sixth. I'll be writing them in the sequence 1 1 1 0. For second equation 2v plus x 0 2 0v. For third equation likewise fourth, fifth and sixth. 6 rows I'll be having. Reducing it into the row echelon form, first I'll be making R3. R3 tends to R3 minus 2 times R1, R4 tends to R4 minus R1, R5 tends to R5 minus R1. No change in R1, R2. R3 is changing. Applying these operations, no change in the last row. Now I'll be making, in the second column I'll be making zeros below the leading entry. So I'll be applying operation likewise. R3 tends to R3 plus R2. For no change in first row, no change in first and second row, R3 tends to R3 plus R2. R4 tends to R4 plus half of R2. It will be half of R2. Same for R5 to make maximum zeros. Apply them carefully. For R5, R5 plus half of R2, 0, 0, minus 2 plus half, minus 3 by 2. R6 tends to R6 minus half of R2. So by checking in the last rows, I can see the last 5th and 6th row can be made 0 row with the help of 4th row. And 4th row can be interchanged with the 3rd row so that the zeros rows are at the end. So I'll be getting in all 3 conditions. 3 rows are independent rows. So dimension of intersection will be 4 minus 3, that is 1. This is the correct option. C option is correct because this is mentioned in C. Dimension of W1 intersection W2 is 1. So this one is correct. For some part, we can just check dimension of W1 plus dimension of W2 minus dimension of intersection. So we have already found these. 2 plus 1 minus 1, it's 2. But in option it's given as 3. So D is also incorrect. So answer is only C part. Dimension of W1 intersection W2 is 1.